and I'll be walking you through a quick introduction today before we jump into our workshop materials. If you haven't yet, please do check out the link to Discord. This is going to be extremely important for today's workshop. All of our troubleshooting and support is going to be happening on Discord, and I also am really hoping that we can hear from you all how we're doing in terms of pacing. And this is our first time trying this out, this online format, so we have a lot to learn, and your feedback is extremely valuable to us. So if you're having any issues getting into the Discord server, I'd like to walk you through a couple of the steps really quickly here. So inside of the Discord application, either the desktop or the web version, you can click the Add Server button, which is on the left side of the screen, and then you can click the Join a Server button, which will allow you to input the code for the Magic Leap Discord server. So go ahead and type this code in, make a note of it really quick. It'll be up on the slides for another couple minutes, so don't sweat it if you miss it. But that's the way to get into our Discord channel. So we have it set up in a really particular way to make sure that we're able to provide support as quickly as possible when anyone has questions. You'll notice on the left side in the list of channels, there's a category for online workshops. And there's a couple that I want to call out, a couple channels that I want to call out. So first is general. This is a standard place to just show up, say hello, get things figured out. We're also going to be dropping moment by moment resources into this channel for you. So videos and links to documentation will be here. So you can keep up with the lesson there. If you have any thoughts, any feedback, any issues viewing, or things that you'd like to let us know about, please just drop a little note into the workshop-feedback channel. We'll be going over all of the messages in there and working those pieces of feedback into our next go-around when we do these online workshops. We're also going to have a survey at the very end. There's a link there that's available, that's pinned there, so please check that out. And then the most important channel for today is going to be the workshop-help channel. That's where we have a number of Magic Leap employees on hand to help you out. If you're having any issues, if you have questions, that's your first line of support. Please jump in there and ask. We also are going to have a couple different audio channels. This is for if we're not able to get you figured out in the by text in the workshop-help channel. Our mentors may invite you to one of these audio channels to be a little bit more direct in working through an issue. And if we're seeing that there's a couple people having the same issue, we also might take a group of participants into one of those channels to figure things out together. A couple other things about Discord to note before we get going here. Every channel will have a handful of important links that are pinned to the channel. You can access these using the pin icon that's in the upper right-hand corner of the Discord client. Again, this is if you're on a desktop application or if you're in the web version, it's up there in the upper right. You tap that button and it will drop down a set of links to resources for the workshop, as well as things that you'll have access to going forward. We had a couple people ask about, will these resources be available after the workshop? And these links will stay up. So you will be able to download and work with these assets. Quick note, though, that the workshop assets themselves are not supported. So they kind of are what they are. And if you have any issues, you can always come to Discord and ask questions, and we'll be able to help you out with that. Last thing to note about Discord, anyone who has an ML prefix on their name in red is a Magic Leap employee, and they're here to help. So these are going to be our mentors today, and they'll be in the channel to support any questions. And going forward, if you come back later this week or after the workshop, we'll be here to help. So want to make sure that everyone has a working environment today to follow along. And even if you don't, that's okay. There's still a lot to learn and a lot to gain just by watching. And again, these resources will be available after the fact as well. We have a few people who are interested in following along with Zero Iteration. If you have your setup working and it's going smooth for you, that should work. No problem there. If you're having trouble getting it going, then I'm just going to ask that you stay with us, you watch, you ask questions, and we'll be able to help troubleshoot zero iteration issues after this workshop. But probably for the duration of our time together right now, it's a little bit better if we just kind of follow along and we can work out kinks in zero iteration after the fact. So in order to get going, the most important piece to start from is the Unity project template, and make sure that you've got version 0.24.0. So this is available up on GitHub, and there are links in the Discord channels if you weren't able to get those yet. It was also emailed to you before the workshop began, so you can reference that original email. The next thing that you'll need once you have the Unity project template and you've opened it in Unity is you're going to need the MLTK package. And this is really the content that we're going to cover in today's lesson are some of the features from this MLTK package. So you can download that. There are also links available in the Discord channels. And finally, we have just a handful of assets that we'll be using for today's workshop. We're going to have a brain asset that we're going to be hooking up to the MLTK features as a way for you to get familiar with those features and to figure things out. So the theme of today's workshop is medical. However, these tools are applicable to any domain, whether you're in automotive, if you're in education. These are general tools that should work for anybody. Quick note, just make sure that you try to import those workshop assets after you've already imported the MLTK. It's also helpful if you have set the build target to Lumin before doing any of those other imports. So, just as a quick reminder, just make sure that you go to your build settings, select Lumin as the build target, and press the switch button to make sure that you're on that. Make sure, please, that you've downloaded the SDK version 2.4.1 from the lab, and also make sure that your Unity installation is pointed at that particular version of the SDK. Anything that's configured inside of the build settings or the project settings, that's specific per project. Anything that you configure inside of Unity's preferences window is a more global thing that exists for all of your projects with that version of Unity. So just make sure that you've got the latest version selected there for today's workshop. And then finally, we want to make sure in order to build to a device that you have your certificate and private key set up. If you've already done the Hello Cube workshop and you were able to deploy to your device in that exercise, you should be good to go with a very important caveat, which is that if you created your certificates before the 15th of March, there's a new format for our certificates. And so what you'll need to do if you created your certificates before the 15th of March is go ahead and delete those old ones and generate a new certificate. This is sort of a one-time thing that you're going to have to worry about only if you generated certificates before that timestamp. And that will help us make sure that everybody is able to build to their device today. If you have any questions about that process, if you're concerned whether or not your certificates are valid, please jump into the workshop-help channel, and there will be mentors there ready to support you through the process to make sure that everybody's good to go. Last note on the workshop materials is that we also have a troubleshooter today. It's a little utility, just one little C# script for you. And this is a tool that we hope will help you identify any small gotchas about your project setup. And so this is available both in links from Discord, and it's also available in the same repository on GitHub where you got the brain materials. There are 2 package files in there for you. So once you've downloaded that and added it to your project, you can open the troubleshooter by going to Magic Leap at the top of your screen in Unity and then selecting Troubleshoot Project. This will open the window for you, and the window will pop up anytime your assets refresh or you recompile your code or you change your build list. If the window gets annoying or it's in your way, just click the Hide This Window button, and that will stop bothering you. So I want to do one last check-in with everybody. I see that we've got a large number of participants today, which is really exciting. Thanks, everybody, for joining us. But I do want to make sure that everyone has a chance to get into the Discord server. It's very important for us to be able to support you going forward. Again, the process is if you go to discord.gg, you want to click the Add Server button here, and then join a server. And when you're prompted with the Join a Server form, just enter in this code VSUWSMM, and that will allow you to access the Magic Leap Discord server, where you'll find our online workshop channels, and this is where we'll be able to help you out with any questions and look for your feedback. So without any further background, I'd like to quickly introduce what we'll be doing today. So this is a video preview of the application that we'll be working on together. It's as you can see, a small brain that sits in front of you, and we're going to be using features of the MLTK package to allow you to interact with this brain in a couple different ways. And you'll be learning these kind of common design practices that you can incorporate into your own projects. So again, my name is Nate Aschenbach. I am a developer evangelist here with Magic Leap, and teaching today's lesson, our lead instructor. You guys are in for a treat. He's a lot of fun. He's got great energy, Mr. Kedar. And some of you may have met him. Hello, Kedar. Welcome.
Hey.
Welcome to the stream.
Hey, everyone. I'm Kedar. Nice to meet you all.
Some of you who have attended workshops in person in the past may have already met Kedar, but he'll be leading today's lesson. And we also have, as I mentioned, a number of Magic Leap employees on hand to help out with questions, concerns in the Discord chat. So look for the ML prefix for those usernames. So really quick, we already covered some of the environment setup. I want to make sure everybody's ready to go. If you're having any issues, please do hit us up in Discord. We're there to help. We have a number of people on hand ready to go. Want to cover real briefly before Kedar begins, what is Magic Leap what is the Magic Leap Toolkit at a high level? And then we'll get into the actual example for today's workshop. At the very end, I'll pop back in and just let you know some wrap up. And if we are going too quickly, this is our first time trying one of these online workshops, and we know that there's a lot of kinks to work out. So please let us know in Discord if we're going too fast, if we need to slow down, or if we're going too slow and we need to speed up. So really quickly, I just want to do a high-level overview of what MLTK actually is. So it is a set of tools that you can import into a Unity 2019.3 project. Doesn't matter what version of 2019.3 you have. We know that there are several out there. As long as you start with the Unity project template version 24, you'll be good to go for today's workshop. Also do make sure that you have the Lumin SDK 24.1 and that your Unity editor is set to that particular version in the editor preferences. So once you have this project template and it's open in Unity, all you have to do is import the MLTK Unity package file. And this is going to drop a couple of powerful prefabs and components into the scene that you're going to be able to use and reuse for a number of projects. So it's really nothing more complex than that. It's a bunch of prefabs and components that you can apply to the problems that you have in spatial computing. So, and for today, on top of these kind of fundamentals, we're going to be adding in the brain assets and just a couple of extra prefabs to help us give us something to work with. So really quick walkthrough of the file structure. You'll notice once you import the MLTK project, there is a Magic Leap-Tools folder available that wasn't there before. If you expand that, you'll see that there are a couple subfolders, art, code, examples, and so you can explore all of these. But really, if you're going to poke around, I would recommend starting with the examples folder. Inside the examples folder, there are a number of scenes that you can pop open and click around and take a look at. Each of these showcases one of the tools that comes in the Magic Leap Toolkit. Today, we're not going to cover all of them, but we do have an aggressive curriculum today. We're going to be covering 4 of the main ones, and these are going to be the control input, the control pointer, the keep in front, and the place on floor tools. So as I mentioned, there's a lot of tools inside of this package, and we're only covering 4 of them today. Several were very recently added. So I really encourage anybody who's interested, either if you have downtime during today's workshop or later in the week, check out these other components and these other prefabs. They're really powerful. So very quickly, just want to do a high-level introduction of the 4 tools that we'll be using today. And as I'm walking you through this, I'm going to be dropping a link to a YouTube video into Discord for you guys. There we go. So, and just to be aware, the video is a little bit delayed for the presenters. So, but I'll be dropping videos into the workshop general channel for folks to watch and get a preview of what these tools look like in action. So check it out in workshop-general. So keep in front, simple component. You can see the properties here that are available to you to tweak in your own projects to make it behave the way you want. Very straightforward. This provides you a way of keeping assets in front of the user in a way that is comfortable, that it's not kind of locked in place with the motion of their head directly, which can be very uncomfortable. This will give you a little bit of kind of a lag motion, and it'll also take into account collisions with the world around you. So next up, we have the place on floor component. And so it's very common in a project for Magic Leap that you would want to identify some space that's on the floor in front of you for you to, maybe place a spawner where bad guys come out, or if you have a rocket ship that needs to fire off, right, you need to identify a little space in front of the user. This just helps you do that. Very convenient tool. Next, we have control input. This is something that helps you hook into the Magic Leap controller using Unity's event system. So if you're trying to capture button presses on the bumper or the trigger, for example, this tool will help you do that in a way that is more straightforward than kind of wiring it up yourself. And finally, we have the control pointer, which I think is the most interesting and fascinating out of today's workshop. You can see that there's a lot of interesting variables that you can mess around with here. And what this does is it allows you to grab and manipulate objects in your space and give them attributes like how much weight do they have, how much resistance, and then give some feedback to the user from the laser from their controller to the object that you're controlling. So I'm only listing like a handful of the components and prefabs that we'll be using here just to give you a quick sense. Once Kedar gets into the lesson, he'll cover all of this in much greater detail for you. So without further ado, very excited to invite Kedar to the stream. And you guys are in good hands. I'll be here watching this Discord channels to make sure that if you guys have questions or thoughts or concerns, I'll be bringing those into the lesson and making sure that Kedar knows about them. But without further ado, Kedar, please take it away.
Hello, everybody. My name is Kedar, as Nate mentioned. Thank you for such a wonderful introduction, Nate. As I'll reiterate one more time, if you're not on the Discord channel, that is the place to go. Help and give us feedback. We're very open to your feedback. This is the first time we're doing this workshop type environment online. So all the feedback you guys have is going to be very, very helpful to us in, making high quality workshops and the workshops that you all want kind of moving ahead as well. So the other thing I'll say before we dive into the workshop materials themselves and start building things in Unity is pinned in the Discord is a link to this slide deck. And I definitely recommend for those of you who are following along and have your environment set up, to download that PDF and follow along with us, because we'll have steps in the slides. But when I switch from the slide deck presentation over to Unity or the lab or something else like that to kind of actually build it, it'll always be helpful to have the steps with you so you can follow along. Oh, I'm doing this. All right, I'm going to go do this. And I'll also give space for you all to build. So each step of the way, what I'll do is I'll tell you what we're going to build. I'll build it and ask you guys to watch. And then I'll pause and then let you all kind of take the same steps on your own and give you a little space to ask questions and figure it out yourself. As Nate also mentioned, if you have zero iteration / the simulator set up with your Magic Leap device or without, awesome. You'll be able to iterate right alongside us with this project. If you don't at this point in time, that's no worries at all. If you have a Magic Leap device and you don't have zero iterations set up, what you can do is you can actually build an MPK to device, and we'll have pause moments where it'll be a good time to actually build the device and deploy it if you have a device set up with you, but you don't necessarily have zero iteration working. If you don't have a device and if you don't have zero iteration, but you still want to follow along, great. I recommend still going through the process and joining along with us, or just watch. So whatever suits you. So without further ado, let's dive right into the workshop. So what do we have here? There we go. Got my mouse focused back on my slide deck. So by now you might have imported the workshop Unity package. This is the kind of file structure of what we have. We have scenes, we have prefabs, scripts, and the model. So we have one real asset that we're going to be working with that is unique to this project, and that's this brain asset that we're going to be building off of and actually adding MLTK functionality around. The goal of what we're going to be building is today is we want to build a fully interactive brain that lets us grab each component, exceed space, and actually UI prompts that kind of tell us a little bit about what this area of the brain is about. So we've got like the left hemisphere, the right hemisphere, the cerebellum, and have little UI prompts that do that. Have the ability with the controller to scale, rotate it, move it around, have some UI feedback sounds, and some general UX design around this. We're going to teach something. Get right off the ground and get to a point of a patient idea pretty quickly. Am I lost?
We lost you for just a moment there, but it looks like you're back.
All right. Let me know if it happens again. I can switch to a switch to a hotspot if need be. Thank you all for your patience. Internet connections are funny in these COVID times. So, where were we? Did you catch the last thing I said about these workshop materials, or do I need to rehash anything?
Let us know in the Discord chat, everybody, what you're thinking, how you're doing.
Cool. Can you guys still hear me okay? Just want to do a quick check. Nate, feedback?
Yeah, gotcha, man.
Awesome.
Sounded great.
Great. So without further ado, let's dive in. Oh, I had one last comment to make on this previous slide. So we have 4 different modules, and these modules we're going to be going through one by one. In the very first module, we're going to be setting up place on floor and keep in front to get the app content, which is the brain, appearing in a convenient spot in your room or play environment, whatever it may be. And that's going to be the first module. Then we're going to add some control pointer functionality to it and bring in input control and have the ability to interact with it. Then in part 3, we're going to be adding some finesse to that control. We're going to be doing some simple scripting to clean things up and allow us to recenter the app and add some finesse to what we're doing, basically. And then in the last part, we're going to be adding some UIs and UI control functionality, some user experience around that. And all of that, we're going to be using the 4 MLTK features that Nate was telling you about earlier. So in each scene, there's going to be a completed scene to help you along the way. So we have a starter scene called MLW Brain 001 Place on Floor Starter, and this is in the Assets/Scenes folder. If you all can open this one up, this is the place we'll be starting together. And then each step of the way, as we complete a major set of features, we're going to have a completed scene that's associated with it. So if you get lost at any point in time in this workshop, we'll have pause moments where you can either like move ahead and join us by opening this completed scene, or if you're not interested in building in real time, you can just open the completed scene and look at all the things that we're teaching in real time. And with each completed scene is an associated completed brain prefab. As the brain prefab evolves, we're going to be adding components to it. We're going to be adding scripts to it, and there will be an associated prefab with each scene as you can go. So this is kind of the index of what we're doing, and this should be helpful for you on your way. So without further ado, place on floor. So the first thing I'm going to be doing is I'm going to be starting with the starter scene, MLW 001 Place on Floor starter scene. We're going to go through, we're going to add the brain prefab to it, which is basically the model right now. We're going to put it in the right location. We're going to make sure we rebuild the lighting and at least have it rendering in our scene okay. So I'm going to hop over to Unity, and if you want, I recommend watching for the first time. Some of this stuff for some of you intermediate Unity devs might be a little slow or straightforward, or it might be quick. Let us know in the feedback section how the speed is going. We'll modulate and work with you guys to make sure you're all getting as close to success, if not full success, if possible. So I'm going to go ahead and tab over to Unity right now. And right now in Unity, I have nothing open right now. I've just got this empty untitled scene, but I've got all my environments set up, and I've got all my Unity packages imported and basically ready to go. And so I'm going to go ahead and hop into assets / scenes / brain 001 place on floor starter. So as you can see, there is this completed workshop scenes folder that you can always come back and refer to at any step of the way. But we're going to open the starter scene, which right now only has 2 things in it. It's got an empty rendering object at the origin and a main camera, as well as this utilities game object and an ML spatial mapper. So for those of you who've developed on Magic Leap with Unity before, you might be familiar with the ML spatial mapper game object. This is our prefab for being able to set up a mesh in your space. So right now, if we were to launch this application on our device, we would basically just have mesh data appearing in Unity, or rather in our application. It would just be allowing the mesh to come in. So to say building to device, and you're not using 0 iteration, or set and check your project manifest, which is under edit project settings. Made that mistake. So under edit project settings, at the very top, you should see manifest settings. To use world reconstruction, you privilege, and throughout the we're going to be using controller pose as well, and that will be the use that we're going to be using for this workshop. So I'm going to go ahead and close this. All right, back. All right. I'm going to keep going with this Wi-Fi connection for right now in this moment. And when we get to a pause, what I'll probably do is I'll flip over to my hotspot, and we'll see if that improves things. Typically it does. So no worries, no foul for right now. And we will keep going. Let us know. Yeah. If it's truly undoable. Where were we? We were in the scene. I was kind of explaining the lay of the land and our manifest setting. So I'll just explain that one more time real quick. Under project settings, edit / project settings, your manifest. You want to make sure if you're building to device that you check at least world reconstruction at the bottom, as well as the controller pose checkbox.
Hey,
if
Kato, I'm
you're
gonna
using 0
jump in here
iteration,
real quick. Sorry
you
to
will
interrupt
be
your
able
flow,
to.
but I'm gonna have you switch over to data real quick. And so I'll jump in and let me grab the screen share here. And what I'll do is I will just cover a little bit of what we were going to cover at the end of the presentation for you guys. In terms of kind of the wrap-up materials, things to keep in mind for going forward and for the rest of the week. And then once Kedar returns, we'll be able to pick up where the lesson had left off. So let me just jump over here. So real quick, at the end of today, please do make sure that you fill out the survey. And that's going to help us out big time. Obviously, we're working through some kinks for the first time, having tried this format out. Having a great time so far. Please do let us know how you're doing and how we can improve. So please do check out the ML Dev Jam program that we have running until May 31st. This is a time to build and then submit a project and get a reward. All developers are invited to participate. The spring 2020 ML Dev Jam theme is Hack Your Workspace. The links to the registration page are on the slide right now, and then you can also hit us up on Discord if you have any questions about that. And then next up, let me just get this back here. Also, please do apply for Access Hardware. I know that many of you are already a part of this program, and it's something that we're very excited about. If you're a developer, if you're looking to get your hands on some free hardware, this is the program for you. We already have some really amazing submissions, and we're looking forward to more in the very near future. In order to check that out, please apply at magi.ca /hardware. So Next up, let's see, we also are excited to talk about the NIST, the National Institute of Standards and Technology CHARIOT Challenge. This is a $1.1 million open innovation initiative that's designed, it's in order to design Magic Leap interfaces for first responders to simulate emergency disasters using IoT data. So very exciting application of this kind of technology. This is a way for you to try out a new idea, potentially get together a new team, or if you already have an existing team or company or business that's involved in spatial computing, this could be a very exciting application and a very exciting thing to pursue. So we also would love to stay connected with you. So please do, if you're not already, please do check out the forum.magicleap.com URL. So that's where you'll find all the forums and be able to connect with other leapers and other folks who are working with Magic Leap hardware to create amazing things, amazing experiences. Please do join us on Twitter. Magic Leap Devs is the handle there. Amazing content coming out all the time, spotlighting things and experiences that are built in the community. And then last but not least, please do stay with us on the Discord channel. That's a place for you to remain connected with Magic Leap employees, as well as other folks who are building experiences on the platform who are really excited about things coming together here. So it looks like we've got Kedar back in action here on a new internet connection. So let's hand it back to him. Kedar, are you there? Second here. Let's see if he was able to reach. I do see in Discord that he should be around shortly. So again, if you're having any issues, please join us in the workshop-help channel. Oh, there we go. Welcome back, Kedar. How are you?
Hey, how's it going? Can you all see my screen?
Sure can, and you're coming through loud and clear, man.
Beautiful. All right. So thank you all for your patience with that. These technical glitches happen. So where were we? I was just going through the beginning of our scene and kind of the lay of the land of our empty scene. We haven't really done anything to our scene yet. So hopefully you've all had a moment. If you've been still catching up with your setup, you're now caught up now with that little technical glitch. And we'll go ahead and dive into the workshop materials for real now. So now we have our empty scene. We've got our privileges set up. We're good to build. And the very, very first thing we're going to do is we're going to go into our prefabs folder. And we're going to grab the Brain Prefab 001 place on floor. And we're going to go ahead and drag it into our scene. But to keep my scene clean, the very first thing I want to do, I'm just going to create a little content parent that's going to hold all of the rendered content in the scene. So I'm going to go ahead and make a content game object. You can right click in your hierarchy and say create empty, and it'll create a content game object for you. And I'm going to go ahead and place it at the origin, 0, 0, 0. And for those of you who are maybe newer to Magic Leap development, the origin on the Magic Leap device is based on where you boot your device. And where your device gets booted is going to be where it assumes the Unity origin is when you're inside of a Unity application. So we want our content and everything to be based off of the origin and keeps things really clean. And so right now I actually have my device on my desk right now with me. So my origin is actually slightly to my right. So just an FYI for those of you who are developing. So now that we've got this content game object, I'm going to go ahead and bring my Brain Prefab to become a child of this content object. And now I have my Brain Prefab in the scene. We can see that it's black and not lit. And we're going to go ahead and light it. But first, I want to make sure my Brain Prefab is in the right location. So I'm going to go ahead and make sure my position is at 0, 1, 0 in the transform to the right. And I'm going to go ahead and make sure that my scale is at 0.25, 0.25, 0.25. And that it's a child of my content that's at 0, 0, 0. And now we've got some content in our scene. So if we were to deploy this, we would see an unlit brain. We wouldn't see anything. So we need to go light it. So we can go to Window, Rendering, Lighting Settings. And if we go to our lighting settings, we can just scroll to the bottom and just regenerate our lighting. And it should take a moment to make the lighting. But now, once we do that, we should have an evenly lit brain that we can see in our scene. Now that we've got that, I'm going to go ahead and save this as a new scene. that I'm building with you live. So I'm going to save it as live workshop. I'm going to put it in my scenes folder just so I can maintain my example scenes to always have a reference to. So for this, I'll actually see 1 meter over wherever the device thinks the origin is. But maybe you started your device in an awkward place and you don't know where your end user is going to be starting the device and what room they're going to be in. So one of the most important things we can do to help improve the user experience of our device, of our application, is to give the users a chance to set the starting place to somewhere that works for them in their room. So the way we can do this is using the MLTK place on floor and keep in front scripts. So before this, I'm going to give you guys a moment to do the same thing. If you've had a moment, set up now. I'm going to go ahead and move back to the slide deck, leave these instructions up. Is everyone following along okay? Is this pace good for everybody? Please let us know in the feedback.
Yeah, it looks like we've got a couple questions. So there's a question about generating new certificates. So I'm just going to call out, if anybody has questions about certificates right now, please jump into Workshop Help 3. Just click on that audio channel there, and we'll get someone into that channel to help anyone with questions about new certificates taken care of. We'll be able to walk through everybody together in Workshop Help 3. So please join that channel right now. If you have questions about the content itself, about where particular assets and prefabs live, please drop those into Workshop Help, and we will have our mentors taking a look at messages in that channel. And I'm seeing just a little. We can probably slow down a little bit. Sounds reasonable to me. Cool. So yeah, that's take it away, Kedar. Sorry to interrupt.
No, perfect. This is the time to do that. So now that we've got our brain showing up in our scene, the next thing we can do is set up a starting place for our application. So what I'm going to do next before I come back here and pause for the next pause is I'm going to go ahead and set up our place on floor utility in MLTK and put it under a new game object called utilities. I'm going to add the place on floor to it, give it a quick GUI, and give some references to all of that so that our place on floor script knows how to do that. I'm going to explain how that works a little bit as we set it up. And by the end of this little section, you should have the ability to launch the app, place it on the floor, and see the brain content appear. So, switching over to Unity, we have our scene with our brain, and the very first thing I'm going to do is create an empty game object once again and place it at the origin and call it utilities, keeping my scene nice and tidy. 0, 0 in position. And I'm going to create a child game object of that to hold MLTK's place on floor. I'm just going to call this place on floor. This game object is going to be called place on floor. And that's perfect. And I'm going to leave it at that for right now. But actually, no. I want to add the component place on floor to it. So if we go to add component at the bottom of our empty game object, we can go ahead and add the place on floor script by just hitting add component, searching place on floor. And if you have MLTK, it should automatically pop up. And it should automatically add the spatial mapper throttle script, which is basically pulling the ML spatial mapper in the scene, checking that it exists, and getting raycasts from it. And then the actual place on floor script, which runs, basically looks for the mesh and looks for an acceptable place on the floor of our room that is flat and can hold the content. And it's waiting for the user to actually look at a position to place on the floor. So it's going to wait for a couple seconds, and it'll allow you to find a place on the floor, and based on wherever head pose is looking, it will find that spot and be like, yeah, is this a good spot? Send a raycast from head pose to this location on the floor. Oh yeah, that's a good spot. And you've been looking at it for like 0.2 seconds. We're going to use that as a starting location, and we're going to spawn this content, whatever game object we have in this content field, in that location. So, and we also can give it some instructions to tell the user to look in that location. And then when we've placed our content, we can get rid of those instructions, and place on floor takes care of all of that. So luckily we have some placement instructions in our prefab. I'm just noticing in my scene, I made a duplicate utilities game object. So I'm going to go ahead and drag utilities, my place on floor under my first utilities, and just delete my other utilities game object. Got a little over organized there.
And real quick, for anybody who wants to follow along with the slides, those are being posted in workshop-help. So if you want to take some extra time to stop and read through the content on those slides, please check it out. Josh N is posting screenshots there. And then we'll also try to keep the slides up on stream a little bit longer going forward.
Definitely. Yeah, so like they just mentioned, we're on the middle of the set up a starting place for our application slide. I believe, I don't know what slide number that is, but it looks like chat's on it right now. So I'll continue on with that slide, and I'll wait till the end of it to pause and put that slide back up in the presentation for you all to catch up. So right now we've got our place on floor script set up, but with no references to instruction or our content. So we can go ahead and quickly give it a reference to our content game object. So what it's going to do is when we find that acceptable place on the floor to render the content, or to place the content, it will drop whatever game object reference it has here, which in this case is the content game object that we have here, at that location. So if we notice this is at the origin, so it'll place it right at that location, and then where this child, this brain prefab child, will appear 1 meter above that location on the floor. So that's why we've had to have the position set to 0, 1, 0, because we don't want our brain to be showing up on the floor. We want it to be at least 1 meter off the ground so we can interact with it and see it around eye level. So now that we have a place for our content to go, let's give some placement instructions. So I'm going to create a new game object called GUI, and also keep that one at the origin. And in my assets/prefabs folder, I have an asset called placement instructions. I'm going to go ahead and grab that GUI and drag it underneath this GUI game object in our scene. And then what this GUI is basically just a plain old Unity canvas. So there's nothing fancy going on here. It's a Unity canvas that has world position, and it's got basically a text component attached to it that just says, hey, focus on an open area of the floor to set starting point. Nothing special going on here. However, we want this set of instructions to be appearing in front of the user. So we want them to be able to see the set of instructions and see it no matter where they're looking in the world. So this is where the MLTK keep in front utility is really useful. If we go ahead on our placement instructions game object and add keep in front, add component, keep in front, we can actually just keep the default settings. And what it's going to now do is it'll keep this GUI in front of the camera, offset from the camera's location by 1 meter in front. You can see we have 0, 0, 1 here, and it will follow the camera. And we have these parameters here that let us set the speed of it arriving at these locations. So it'll kind of do like a lazy follow to the head pose, and we can set a minimum scale of how small it'll shrink down if it's getting caught between you and a mesh. And when I say that, it's like, imagine if you get really, really close to a wall. Instead of this canvas disappearing behind the wall, it'll stay in front of that wall, but it'll get smaller and smaller and smaller, so it doesn't overwhelm you in the face. So this is the stuff that keep in front will automatically take care of. So now we've added this. Let's go ahead back to our place on floor script, and we will add this placement instructions GUI as a reference under instructions. And
a great question from Alex Lee in the general chat that got answered. Does place on floor only recognize floor surface or any surfaces like a desk surface?
So I believe it recognizes primarily floor spaces, floor surfaces, and actually, that's a really, really good question.
Yeah,
I've never
so it looks
tested
like
it on a desk. Yeah,
it is a great question. I was also very curious. So
yeah.
It looks like Chris R was able to help us out. And apparently line 165 uses the surface details.analyze function to determine what the surface type is. So if you want to modify the behavior, line 165 is the place to do it. But it'll look for floor surfaces by default.
Oh, thanks for that question, Nate. That's a really, really juicy question and really helpful if you want to modify this for your application and have something particular you want to do with it. So great call out. So now that we've got this set up, this is basically the test scene we have. I'm going to go ahead and save my scene, and I'm going to go ahead and test it. So I have 0 iteration set up already on my computer. I'm going to show you. I've got 0 iteration here, targeting to my ML1, and it's running. And I've got head pose data here, and I also have device stream. So I will be able to show you what's happening in my room while I build this. So I'm going to go ahead and open up device stream and hit play. I understand there's probably a little bit of latency. So I'll go slow here. There's going to be latency from the device stream to the computer, and then from the computer over the network to you all. So you should hopefully be seeing a device stream by now. And I'm going to go ahead in Unity and hit play, and it should automatically play this on my device, and I'll be able to show you in device stream what is going on. So play.
Looks like it's coming up now.
All right, we're loading in ZI. Loading, loading, loading. This is the loading song.
Almost there.
And that's loaded. We can go to device stream, and I can see that I've got this GUI in front of me now. It should say focus on an area of the floor to set starting point. You all can get a sneak preview of my battle station, Discord, device stream, all of the above right there. And here's a sneak preview of my room. This is where the magic happens. And focus on an area of the floor to set starting point. So it looks like it got a raycast somewhere way back there. But now you can see inside of my mirror that it rendered the brain over there. So if I was looking at the floor, it would have rendered the brain over there. And now I've got a starting place for my application out yonder. So now that we have that set up, we know that our scripts are working as we expect. And as you saw, the place on floor script, the keep in front script allowed the GUI to stay matched with head pose the entire time. So I'm going to go ahead and pause my device stream and go back to the slides and give you all a moment to catch up.
Looks like we have a couple questions about, let's see, the simulator in general. So any questions, would love to field those. Jump into workshop-help, and we have folks ready and waiting to help out. Again, like if the 0 iteration is giving you any headaches, we're going to be helping folks with that a little bit after today's lesson. If it's causing you issues, definitely invite you to please follow along in Unity, and we'll be able to help you out with 0 iteration bugs after the fact. And then if you have any questions about the content or what we're doing today, please jump into workshop-help and we'll be able to help you out.
Yeah, I have a lot of mirrors in my room. It makes Magic Leap development or just Magic Leap use really, really weird sometimes. Like it actually sees through the room and like sees the reflection of my room as another room sometimes, and it's trippy.
So, and again, we'll have the slides up on the live stream, but they are also available in workshop-help. So Josh N is putting up screen captures of each of the important slides. So if you want to dig into those a little bit more, please jump into that channel. If you have any other questions or comments, or if you're having some success, we'd love to hear about it in the general chat. If you're just watching on Blue Jeans and you haven't yet joined us on Discord, it would be great to have you, great to hear from you. There is a question in the Blue Jeans application. If you click on the, where to go, on the question and answers, there's a question in there about getting onto the Discord server. So want to make sure that everybody who is able to get onto Discord, we have them there today. And if you have any questions about that, please let us know. Looks like we have some folks getting it working in 0 iteration. Great to hear.
Oh, that's awesome. Love that. So Nate, I heard you prepped some dad jokes for these pause moments.
Well, I heard that dad jokes are the way to surf through any dead air that might happen on a webinar.
Oh
We've been,
man.
yeah, we've been doing our research and found that it helps keep the energy light and lively.
That's what the market research shows,
It is, yeah.
online workshops are best stimulated by cheesy jokes, including this cheesy joke referencing cheesy jokes.
I know it's a hall of mirrors, man. Goes all the way
Yeah.
down.
So let's see. I
Let's
think
check in
what I'll
with,
do.
yeah, go ahead.
Yeah, I was just going to move to this pause slide. So we are kind of in a pause state already, and hopefully some of you all have the PDFs downloaded into reference kind of what's going on. But kind of at each module endpoint, which is where we're at right now, we just finished MLW001. We've got these summary slides that let you go back to different parts. So by now you should have added the brain prefab to the scene, created reference to the content object and the place on floor component in your scene, and these should have slide references set up for you. So if you're not sure which step happened where, this is a good place to come and see the review of all the things that you should have done. So these are all clickable links and in the PDF itself. So if we're all feeling good, we can move on to the second part of our workshop, which is control pointer, module 2. The first thing we're going to be doing, I'll give a little summary. So control pointer, what we're going to be doing in this little module of our workshop is we're going to be setting up MLTK's control input and control pointer features and just enabling use of the control in the scene in general. We're going to go through, bring all that into our scene and allow all the little brain children game objects, like each component of the brain to be interactable. And we're going to set that up and add the scripts that'll allow that. And we will go ahead and also set up a little utility script that'll let us quit and go back to home when we double tap. So we'll start using some custom functionality with the default MLTK tools and allow us to go back and restart the application if need to and quit out of it pretty easily.
And quick question from chat. Should they be changing scenes right now or should they stick with the same scene that they have going?
So if you're building and you're all caught up and you're following along, keep on going. We're going to be building right off of where we were. If you are feeling lost and just want to see a completed scene, or you want to start from a completed scene and start following along with us right now, then you can open up the mlw.brain.002.controlpointer.unity scene. This is the finished scene. But if you want to start from somewhere, you can open up the mlw.brain.001.control.place on floor completed scene. So I'll show you that when we get to Unity again. But the first thing we'll do when we get to Unity is we're going to actually set up the control pointer in our scene. But I'm going to switch over there right now, and we'll come back to the slide, which basically talks about how we can get that prefab into our scene, and how to get the control pointer set up. So we'll come back to the slide deck in a second. Hop over to Unity and I'll show you where these completed scenes are and where you can jump back in if you're feeling lost by any way, shape, or form. Okay.
Cool.
So
we've got a good question about, let's see. So experiencing compilation errors in show UI _complete. The error is pointer receiver. The question is, have you tested it in 2019.3.7? And so, yes, we have. I do believe that I bumped into that when I was setting up my project yesterday night to test things out. And the core of the issue was that I hadn't switched my build target to Lumin before making the imports, and my scene got confused about that. So my fix was to shut down the Unity editor and delete my SLN file. If you have any further trouble with that issue, please jump into workshop help, and one of our mentors will be there to help.
Awesome. So just to reiterate, under assets/scenes, if you want to start with a completed scene and follow along, you can open up MLW Brain 001 place on floor complete and follow along with the second module. If you want to see the completed version of what we're doing right now, you can see that at MLW Brain 002 complete. So these are the scenes under assets, scenes/completed workshop scenes. So I'm going to continue building off of what I have under my live workshop scene. If you have your own scene where you're building and following along, I would continue working there. And the very, very first thing we're going to be doing is just getting our control pointer in our scene. We just want to get enabled with the control pointer and be able to see a controller in our screen with ArrayCast. So that's actually pretty easy to do. To keep our scene organized, I'm going to create an empty game object once more and call this one input to kind of hold our controller prefab. And once again, I'm going to set that to be the origin. And in there, I'm going to grab the control pointer prefab. So the way I'm going to access that quickly is in my project window in Unity, in the search bar, I'm going to type in control pointer. This prefab control pointer is actually located in MLTK. It's not part of the workshop files. This is shipped with MLTK. So if I go ahead and clear this, we can actually see that it's located in assets, Magic Leap tools, /prefabs, /input. And then we can grab this control pointer prefab here, and we can drag it into our scene under input and keep it at 0, 0, 0. So this contains a lot of stuff right off the bat. This contains a line renderer for the raycast that we're going to be using, and it allows you to customize settings around how the pointer looks. We have this pointer script, and this pointer script is part of MLTK and customizes the bend and the extent to which the pointer goes and some of the pointer physics that are around it. Off the bat, it'll be kind of a bendy pointer. We have some settings in our slide that we like to use to make the pointer a little stiffer to add some agility. You don't have to use these properties. You can use the default properties if you want. It's up to you. And if you're feeling adventurous, you can customize these properties. So for me, I want my pointer to be a little longer. I'm setting it to go out to 2.5 meters and having the minimum distance be a little bit farther out as well. It's about the size of my room. 2.5 meters is a good size for the room that I'm in. And I want the bendiness to go down a little bit. So I'm going to set in my pointer script, I'm going to set my bend weight multiplier from 1 to 0.25, percentage down to 0.25 as well, and the bend prediction multiplier down to 10. Again, this part is totally optional. It should work right off the bat. So that's the pointer script, and then there's the control input script. This is another one of MLTK's major features. The control input script basically allows for you to have event callbacks on all of the various button presses that can come through the Unity controller or the Magic Leap controller. So like as you can see, we've got on control connected, disconnected, trigger up, trigger down, and we can assign event callbacks in any custom scripts you write and assign them in an inspector. And it makes things super fast for having some immediate feedback on control buttons from a prototyping perspective. So now that we have the control pointer set up, I'm going to go ahead and, oh, by the way, we also have control haptics set up here. So by default, haptics are enabled when you touch the controller. You can and can't remove this if you want to. And then we have some of the basic control input driver scripts that are key for the Magic Leap controller to work. I'm going to pause here and pull up the directions again and make sure everyone's able to get this prefab in their scene and caught up. And at this point, if you were to test, you would only see the raycast. Like you wouldn't be able to actually control your brain. You wouldn't be able to necessarily grab or interact with any of the components because none of that is set up yet. It's just a model with a mesh. There's no colliders. There's nothing on it to help allow us to receive feedback. And that's what we're going to do next in this module.
Some interesting questions coming out of chat. Do any of the scripts or components look for specific game object names, or are they arbitrarily named? So I'm thinking that the question is, do they look for, do they do like a game object dot find for game objects that have a particular name, or how does the linkage work there?
So we're going to go over that in a second for actual like how pointer receivers work. There's actually a pointer receiver component that allows for dragging and interaction to occur. As far as what the pointer can even interact with, there's even above that functionality, there's like a layer mask. So you can set, as you can see on the right-hand side, what layers that the pointer can even interact with and make collisions with. And then on top, and then once you're within that layer, it looks for pointer receivers to be able to drag and move and be able to interact with things. We're going to talk about how that's set up in a second, so we can actually grab some of the brain components.
And don't forget about the feedback channel. If anybody has any thoughts on ways that we can improve for next time, this is definitely going to be an iterative process on our end for our team. We'd love to hear your thoughts. So drop a line in the workshop-feedback channel. We also have a survey that'll be sent out to everybody. So would appreciate hearing from you and what you think. And just in case anybody hadn't seen it yet or missed it in what Kedar had been saying earlier, there are a set of scenes in your project that you can use to sort of fast forward to the particular spot that Kedar's instruction is at. So if you feel like you're falling behind or you feel like you may have messed something up in the scene that you're working in, you always have those scenes to fall back on. And if you do want to continue troubleshooting on a particular issue that you're having in your own scene after the fact, we'll be in Discord to help you through that as well.
Awesome. So I'm going to keep moving a little bit since we've got a lot of material to go through. And the next thing we're going to be doing is we're going to be adding some pointer interactability to the brain model. We're going to go ahead and set up pointer receivers so we can have the game object know. We're going to set up, make sure our mesh renders have mesh colliders as well so that the raycast can collide with it. And we're going to be setting up the MLTK's input feedback component as well, so we can get some feedback when our pointer is interacting with it, whether it's selecting it or dragging it, and get some feedback for our user so we know if it's working or not. So hopping over to Unity, we have our control pointer from last time, and under content, we have our brain prefab from part 1. And under this, we have basically all of these individual brain components that just have mesh renderers attached. So nothing crazy going on, just a model. So what we're going to do is go ahead and select all of these individual brain game objects that are going to be interactable. And to all of them, we're going to add a few components at the same time. So the first thing we're going to add is a mesh collider. And this will allow the raycast to collide with the mesh. We want to set the mesh to be a convex mesh, and we want it to have an interactable physics material. And if you go ahead and click this little search button here, MLTK has a pointer interactable physics material that sets some properties around the collider. And that's the first thing. Then the next thing we want to do is add the pointer receiver component. And this will automatically add a rigid body to our component as well. So I'm going to go ahead and hit is kinematic, because at the end of the day, while it would be fun for all of these brain components to bump into each other and move around the scene with physics, this is an educational app and we want things to be finite and in control. So, or we could turn on gravity and have it all fall and hit the mesh. But that's up to you. For now, I'm going to keep my settings at is kinematic. And then the last component we want to add is input feedback, and add component input feedback. And this will basically highlight the mesh at different colors when the pointer is selecting it or dragging it, and give us some feedback. It also has audio clips referenced to it. that you can add in custom audio clips to give custom feedback. MLTK has some stock sounds that you can use by default. So I'm going to go ahead and use those stock sounds. So I'm going to click right here and grab a target begin sound here in my scene or in my project and do that for each one of these. So now all of my components are going to be interactable. Drag start, drag stop, and collision. So from a design perspective, this component is actually so helpful. When you are interacting with things in mixed reality, you really want to make sure that you're getting some kind of feedback from your game objects. You know, both the visual and audio feedback paired together really gives the user a sense that, oh yes, like what I'm doing is actually doing something. And it goes a really long way in making some of these interactions feel good and organic. So I'll actually take a pause right here. Well, I'll give it a quick test so you can see what's happening right now. I'm going to go ahead and hit play. I still have 0 iteration running, so I can hit play. And while that loads, I'm going to open up my device stream so you can see what's happening. Oh, device is in standby. I thought I turned that setting off. All right, let me kick it off of standby mode really quick. Awesome. So here we are. I've got my prompt to focus on an area of the floor. So I'm going to focus on this area of my floor over here. And sure enough, there's my brain a meter above the area that I was focusing. And I'm sure there's a massive lag, right? So I'm going to wait a second. And you can see that I have this control pointer in my scene now. And it's following along wherever I'm moving my controller. So we're actually tracking the controller 6th off right now, and that's already enabled. That was enabled in the previous step when we just added the control pointer prefab. And then, as we can see, that I'm just pointing at these game objects now, and the input feedback component is giving us color feedback on our mesh, and I can actually hear audio feedback locally on my side that we're selecting it. And then when I hit the trigger, I can actually drag one of these components and move them around. So boom, I can actually drag, pull it out, move this around. But you might notice if you're following along and caught up that we can't actually scale or do anything with these objects yet. We can't rotate them, scale them. We're just changing their position. And the next thing we're going to do after this is we're going to enable that functionality as well.
Okay, there's a great question from Chad J about standby mode. Where does that setting live?
Yeah, that setting lives under settings/devices. I believe all the way down in developer mode. I really don't remember the menu locations by heart. I think somebody in chat might be able to be more specific than me right now. I'd rather not turn off 0 iteration and hop into my menus at this moment to get too sidetracked. But yeah, you can absolutely set up. There's a high performance mode in your device settings that lets you keep the device not in standby mode and prevent it from going to sleep and this is particularly handy when you're developing and maybe iterating with the device frequently. So I like to have that setting off sometimes when I'm just developing, because then when the device goes into standby mode, then I can't really, I have to wake it back up before I can deploy my application. So I'm going to pause my device stream and switch back over to the slides and wait for everyone to catch up to where we are for those who are following along.
Looks like we've Envawa has some success getting the interactions going. She says they feel great. Wonderful. Glad to hear it. Question, how was the brain prefab created?
I think that's a great question for you, Nate.
Well, the place that we started was just doing a Google search for assets that were under a permissive free use Creative Commons license. So we found a couple different brains that were royalty free for use, and we drop those into Maya and mix them around a little bit to optimize them. Maya has some tools that allows you to reduce complicated, dense geometry to something that's a little bit more palatable for a real-time experience like what we're building on Magic Leap. So found some free assets, reduced the poly count on those assets, and then exported from Maya to Unity and applied just basic shaders to each of the different sections of the brain. So if you're already familiar, if you already have a Unity modeling workflow, if you've already used assets from the asset store, it's just the same as any old, FBX import to have a mesh renderer in your scene and then apply the MLTK features to those prefabs.
Awesome. Thanks for that. Yeah, it was super awesome. When we were developing this example application, I was like kind of searching for maybe like a nice starter application that could showcase some of these features, and we were like investigating various things, and we kind of came to a brain because I'm personally very curious about the brain personally, and Nate was just kind of dove in and was like, yeah, here you go, found this model and got it all set up for you in Unity, and then it was smooth sailing. We developed this application over the course of a week, and then turned this application into workshop materials after that. Behind the scenes, it's been a journey to come here, and we're so excited to actually share this application with you right now. We think it's a lot of fun to just kind of use these features and feel them pretty quickly. So, and
yeah, it's been a
really
blast.
exciting. Yeah.
If anybody wants to create your own version of this particular brain app using different models, there's lots of free and cheap assets on the Unity Asset Store that you can download that should be good to go right off the bat. TurboSquid is another great website for finding materials to work with. There's really a lot of great resources out there for very affordable assets, particularly if you're building something for education or for a purpose where you're kind of reusing well-known things like animals or pieces of human anatomy. Things like that are widely available.
All right, so let's move on to the next part of this module. So this is where we can add some rotation and scalability. This is actually a really easy thing to enable because MLTK has some manipulator scripts that work with control pointer right off the bat that you can add to your interactable objects. So basically, I'm going to switch over to Unity and show you how to do this really quick. Oh, I'm still in play mode. Going to kick it out of play mode. And with all of my interactable game objects still highlighted under my brain prefab, I'm just going to add two components to it. I'm going to add the rotation manipulator, which basically has one parameter, which is a multiplier. And this uses the radial dial on your controller. So if I don't know if those of you who are still seeing like the physical version of my screen and not, or my webcam instead of the screen share, you can see I'm holding the control and like you just scroll on the radial dial in a clockwise motion to have the same kind of clockwise rotation, and it just tracks the speed of your rotation. That'll be how fast it goes, and you can change that speed multiplier something at a higher scale or at a lower scale depending on how much agility you want in your model. And then similarly, we also have a scale manipulator script that by default, this scale manipulator script will let you tap on the left and the right side of your touchpad on your control to increase the scale in the however many steps that you set to the maximum scale by hitting right, touching right, and then touching left will decrease the scale to the minimum scale that you set. And then if you force press on the touchpad, it'll reset the scale back to normal. So right off the bat, you can enable this kind of functionality to get some rotation and scalability. So this is so handy to use when setting up any kind of interaction. And yeah, I'll move back to the slide.
Let us know in chat what you guys are working on, what you're coming up with. I know that in the past we've had a couple participants take a screenshot and drop it into the Discord channels. We'd love to celebrate with you guys as you're making progress. Or if you have any questions, please let us know. We are here to help.
Awesome.
Looks
so
like
since we just added, go ahead.
Workshop
Sorry.
audio, workshop help 1, 2, and 3 are decently populated. So if you've been in those channels and it's been working out for you, please let us know in the feedback. We're going to be working to improve our process every time we do one of these. So sorry, Kadar, go ahead.
No, I just wanted to take a moment to give a shout out to our awesome mentors. Thank you all for being on the Discord and answering questions. You all are doing a great job. This is it's awesome to have you guys in the background kind of doing this stuff. It's makes me feel very safe presenting. All right, cool. I'm gonna move on since we just added 2 components there. And the last part of this module is we're gonna set up a double tap home to exit application script. So what we're gonna use is we're gonna use the control input script that's attached to our control pointer. And we're going to use the onDoubleHome event callback to call a custom script that basically just quits the application. So the script, I'll show you all in Unity where it lives in a second, but it basically contains one function, which is just exit app. And it runs application.quit. And it's also got preprocessors to check if you're in Unity editor. And if you're in Unity editor, it'll call the Unity editor's quit application instead. And this is actually a really handy UX feature to add to your app that you can do very quickly that makes it so easy, not just in development, but also in deployment for your user to go ahead and quit the app in a pretty easy way. And this is a great way to kind of show off how you can use control input to really quickly add some functionality to your controller and start utilizing the buttons. So I'm going to hop into Unity real quick, and inside of Unity, I'm going to navigate to the scripts folder. So I'm going to kind of minimize all of my expanded folders here so you all can see. And then in scripts, there's one folder called completed workshop scripts. And inside completed workshop scripts, there's the 3 scripts we're going to be using in this workshop. The one we're using right now is exit on home. And I'm going to go ahead and show you all in Visual Studio what it looks like. This workshop is a little long, so I'm not going to live code it with you, but I'll just walk you through the function again. So here it is, public void exit on app, and then we have this preprocessor check to check if we're in Unity editor or not. And then if we are, which we are right now, we just make a call to Unity editor application, and we tell it to stop playing. And then we have a debug log to let us know, hey, yeah, you're quitting. And then we also have this application.quit here, which is how we'd quit the application if it were deployed to device. And I'm going to go ahead and drag this script now into my scene. And we can go ahead and add it to our control pointer. So if I navigate to my control pointer game object, I'm going to add the component, and I'm going to search exit on home complete and add that. So now that we have that reference in our scene, what we can do is we can open up our control input script on the control pointer game object. And if we scroll down to onDoubleHome, which is searching for a double tap home on the device, we can go ahead and add an event callback that references the control pointer itself, control pointer game object. And because this control pointer game object has the exit on home complete component script, then we can go ahead and call the exit app function within it. So now whenever we hit double tap home on our control pointer, it'll just quit the application. So this is a really handy way to just enable some functionality. So I'll kind of show that off for you right now. I'm not actually going to show this. I don't think I need to open up device stream for you all right now to test this functionality. So I'm going to just hit play, and you all can look at my camera and where I'm holding the control pointer to prove to you that I'm doing what I'm doing. And here we are. We can actually see the mesh has been generated and the UI is there. And if I hit double tap home, sure enough, we should exit play mode. Let us double tap home, exit. let's see. Is this app running? There we go. Sure enough, I had to wear the application. And now we can see in the debug logs, I double tap home, and I exited. This is also super handy if you're even in 0 iteration. You don't have to necessarily hit the play button again to do it. So that's this little bit of functionality. And yeah, I'm gonna go ahead and pause on this, pause on this slide.
We've got some screenshots being shared in general. Thanks for that. Glad to see everybody's making progress and following along.
Also, definitely, if you are stuck in any way, shape, or form, do post to help. We have plenty of mentors here to help unblock you. Man, I'm almost done with my first water bottle. All this talking requires hydration.
You have a backup?
I do. I've got my non-branded Magic Leap water bottle here that I've added Magic Leap stickers to. But then I have my proper Magic Leap swag water bottle to follow up. This is one of the original swag series Magic Leap water bottles. If you've come to our events in recent past, you might have had one of our new edition Magic Leap swag water bottles. They are now limited edition because we are no longer doing events. So cherish your swag.
Well, it's always important to stay hydrated.
Yes,
especially,
absolutely.
Yeah. 2-hour workshops, man. You gotta maintain.
Yeah, maintain. All right. I feel like I want to move on. Does everyone, Nate, you've been keeping an eye on the chat. Does it feel good right now to move on to part 3 and kind of summarize where we are with part 2?
Yeah, we've been getting some great questions and seeing some answers come through in chat. So again, if anybody has questions, please do post those in the workshop-help channel. That'll help us get answers to you as quickly as possible. If you have any progress or screenshots you want to share, please post those in the general chat. And we'll all take a look at that and throw you some emojis.
Awesome. Yeah, so we are now finished with our second module of the workshop. And in this, just to kind of recap what we've done so far in MLW.002, which stands for Magic Leap Workshop, we've added a control pointer to our scene. We've created an exit on home script that exits your application. We've added that as an event callback to double tap on home. We added basic pointer interaction with rotation and scale manipulation from MLTK. And yeah, that's where you should be at this point in time if you've been following along with us. If you are just watching and maybe you want to see the completed version of this scene, you can go ahead and open the MLW.002.control pointer completed scene to see the completed version of this working. And this would be also a good time to open this scene up if you want to start with us and move into the third module at the same time. So that's where we are, and we're about to move on to part 3, finesse control. So in this part of the workshop, you may have noticed if you're testing with the device from before that we actually like once we move the various parts of the brain around our room or our scene, you know, there's no way to reset the brain. We can't, once we do it, they're out and you can't rebuild the brain. So what we want to do here is we want to give some way to like reset the brain back to its original position. And we also are missing a way to globally control the entire brain structure because we just kind of have an empty game object that's parenting all of the actual mesh components in our model. So we want to add some way to control the full brain, and we want some way to reset the brain once we've put it all around back to our original location. So, without further ado, first thing we're going to do is we're going to add a way to globally control the brain model. And what we're going to do is we're going to basically modify the current version of our brain prefab to add a sphere that parents all of our brain meshes. And this sphere is just a typical old Unity sphere. And so what we're going to do is we're going to modify the prefab that we've been working on, and we're going to add a brain to it, or add a sphere to it, and then we're going to add the same scripts we did from part 2 to basically add some interactions. So I actually noticed live right now that I actually have a little typo on this slide. At the end of this little section, we're going to be adding spatialization. So if you look at 3E, I reference an MSA source here. We're going to be adding that to everything together later. So, don't feel like you need to add that right now because we need to add a couple components to make sure that works appropriately with us. So add everything else if you're following along with the directions from 3D. And yeah, and I'm going to do that live with you all right now. So we're going to add a sphere, modify the brain model, and make sure we add the same components from our previous part of the workshop to add some interaction. So I'm going to flip over to Unity real quick. Clear out my console and hop over to content and open this brain model. And the reason we're modifying the brain prefab directly is because if we were to do this in the scene view directly, we would be breaking the prefab instance by trying to add a new game object to it that's a parent of all these things. So there'd be kind of two options from there. Like if we could break the prefab instance and just do whatever we wanted in the scene, or we could modify the prefab itself and continue reusing it and make sure that if we were to use this prefab in another scene for whatever reason, we could maintain the same functionality. And generally, it's good to go with the less destructive operation in this case. So I'm going to actually modify this very first brain prefab that I have to have this functionality. So here we are in prefab view. If you don't know how to get to prefab view, you can select the prefab in your scene, go to prefab, open, and then here we are. And you can see you'll have like a little blue empty scene with our brain lit up nice and bright for us. And what I'm going to do is right click on my parent game object and create a 3D object that is a sphere. And you will see now that we have a very big sphere that is pretty much the same size as our brain. Let's make that smaller. And we're going to make that 0.2 scale all around, 0.2, 0.2, 0.2. And we're going to move it minus 0.5 meters below the brain. So this is what we're going to use with our control pointer. We're going to be able to grab this little this little sphere and use it to drag around all of our brain components and rotate the brain and rotate everything that's a parent of this. I'm going to select all of these components and drag it underneath the sphere. And now when we select this thing, once we have interaction here, we'll be able to, excuse me, I think I have a sneeze coming. It's one of those things where the sneeze is like coming and like I don't want to like sneeze into the microphone and make you all go deaf. We're good. We're good. No sneezes coming.
All right.
The intricacies to live workshops. How fun. Great. So now that we've added the sphere component, we're still in prefab view. Let's add some components. The first thing we want to add, we already have a collider here, which is nice. Let's add the same physics material, the pointer interactable physics material. And let's add the same components from before. We'll add the pointer receiver here. We will add the, we're going to add a, what else do we have? The input feedback. If you would like, I'm doing this manually, you could just delete your prefab and drag in prefab 003 that has this all set up for you already. But I'm just going through the process and adding these things manually. If you want to catch up, you can just drag prefab 003, and once again, I'll show you where that is. Assets/prefabs, prefab 003. We can delete prefab 001 and replace it with prefab 003, and that'll have all of this stuff completed with all the components, including the next script we're going to build after this, also completed. So, but I'll move through that if you want to move through the process fully with us. So where was I?
And thanks again for asking great questions inside of the workshop help channel, guys. This stuff is really complicated. It's not easy to get everything up and running. So please don't be shy. And everybody in here is doing wonderful. So wanted to give a little acknowledgement to the help that's happening right now. Thanks to the mentors and appreciate the great questions.
Second that. This is It's cool. It's cool to be kind of having a slight eye on the Discord at the same time and seeing a lot of you coming to success with this application so quickly. So target begin. Where was I? I'm in the middle of adding sounds. Adding sound references. Collision sound. Beautiful. So now my sphere has the same functionality as the rest of my components. So I'm going to go ahead and save this prefab, and I'm going to head back to the scene. And now we can actually see that our scene is updated, and we have a sphere here with all of this functionality, just like before. So I'm going to go ahead and test the scene really quick to make sure that we can actually move the brain around. Hit play, go to device stream. Might be in standby mode. Yep, device is in standby mode. Sure enough. Let's restart that. Boom. Accept. Oops. Again, I actually hit cancel that time instead of accept on my device stream device prompt. And you can see that I've got my UI here looking for a place on the floor. There's my place on the floor. There's my brain, and there is my sphere as a child, and now I can select that with the trigger on my controller and move the entire brain around, which is awesome. And I can like move things away and whatnot, which is really great. So now we can still grab the sphere and globally kind of control everything. And however, we can't reset the brain component back to normal. And I'm actually noticing now that I actually forgot to add two scripts that we added from the last part of the workshop, which is the rotation manipulator and the scale manipulator on my sphere. So I can radial dial my cerebellum right here and spin it around and scale it up and down and reset the scale. But I can't do that for this sphere object because I haven't added those scripts yet. So I'm going to quit this scene, double tap home to exit. Sure enough, back in ZI. I'm sure you all are catching up with the lag. I wonder how the lag is at this moment between my device stream and my speaking.
So it looks like we've got the demo still live for the users, but quick shout out that people are sharing screenshots in the general chat, looking wonderful. It's so fun to see the progress, everybody. So please keep those screenshots coming.
Awesome. So just to fix my little misstep from before, I'm going to add my rotation and scale manipulator to my brain prefab sphere component. Rotation manipulator, scale manipulator, and save. So I'm gonna pause for a moment right here and acknowledge that it's 12:30, which is 30 minutes away from the end of our workshop time, and we actually still have a lot of workshop material left. So I'd actually love to take a poll of the people who are following along and kind of give you an overview of like what's left, and would be very curious to know like what would be the best way to spend this 30 minutes of time. We have a bit of stuff left to do. We have one script to add, and then we have UIs to add that we haven't shown off yet. So we can keep going and then pivot and just show you guys the last step, or we can keep going and see how far we get. Nate, do you have any thoughts yourself?
Well, we already were able to cover the wrap-up materials earlier in the cast, so that's out of the way. It looks like people are keeping up, and I've been seeing some great screenshots being posted in the general feed. If anybody has any questions or things that we can jump into and explore, we've also have the ability to run a poll for you guys. So let's see if we can get that going. And let me clear up whether that would be a poll that happens in the BlueJeans application or so in BlueJeans, we're going to have a poll. So we're going to provide you a handful of options for how we're going to spend these last 30 minutes.
Oh, this is fun. So option one is I can keep going at the same pace that we're going and try and cover as much as we're covering for the next for the rest of the 30 minutes. option 2 would be for kind of an abbreviated, like step by step. So I will just kind of like add things quickly and demo you what's happening maybe with each individual step and walk through the slide deck pretty quickly so we can get to the end and like maybe take a little bit less time to build. If there's anybody else that has other options, we'll think about it. I'm going to give a minute or two for people to voice their
Great
opinions.
question from the chat. What is MSA source used for?
That's a great question. I'll talk about that in like 2 minutes.
Sounds good.
Yeah, MSA source is related to our audio spatialization, and we actually have a little section on that coming right up that we can go over pretty quickly.
Very cool. We do see Chad J saying he'd love to see the project walk through to the end. Let's see. So our poll should be live in Blue Jeans. Oh, yeah, there it goes. So if you, in Blue Jeans, there's what looks like sort of a chat bubble on the right side of the application. And you can click on that, and it'll give you the poll that you can provide a response to. The options are keep going at the same pace and let's cover as much as possible, or shorten it and go step by step and demo what's happening so we definitely get to the end. So please jump in there and let us know what you'd like to see. We've got, awesome. We're going to give you guys maybe 45 or 60 seconds, and we'll get as many responses as we can. So again, in your Blue Jeans application on the right side, there's what looks like a word bubble in a cartoon comic. If you click on that, there'll be a question there, and you can submit your vote. Let us know what you'd like to see.
This is so fun to watch this poll live. I'm getting a lot of joy just watching the poll. The poll percentages change, but we seem to be having so far a strong preference in one direction. For those of you who haven't voted yet, I'm not going to tell you which preference direction it is.
Okay, getting a good number of responses. So counting down. Get your responses in, everybody. 5, 4, 3, 2, 1. Okay, I think
and the winner is
close the poll out. Let's see what we got.
Shorten it and go step by step and just get to the end. All right. So the next thing we're going to be doing. Oh, Nate, it sounds like you were about to come in with a comment.
Oh, I was just going to say thanks for sharing. There's a video in general chat. Really appreciate that, taking the extra moment to capture the work that you've done so everybody can see. It's so encouraging to see what everybody's up to and that people are having some success. So thanks so much for doing that. If you have something you'd like to share, please do. Even if it's after the workshop today, we'll still be in Discord. And we'll still be around to check it out. You can always share things that you're building in the general Discord channels. So please feel free to introduce yourself in the introductions channel and share in whatever channel is most appropriate for what you're up to. But really appreciate that. Thank you.
Yeah. So what I'll do, slides. This won't necessarily be at a pace where you might be able to like follow along and build at the same time, but you'll at least get all the explanation of what's happening and what I'm doing and what I'm adding. So so the next thing we're going to be doing is just adding a simple script that resets the children, and we're going to add this to the sphere game object, and it's going to go through, and the script is basically set up to hold all the original positions, rotations, and scales of each of the child objects in an array. And then there's a single function in there that we are calling reset child transforms that gets called once we've moved things around and resets them all back to their original position. And we're going to use the on home button tap to call back from control input to basically allow us to do this. So we'll have single home button tap. It'll reset all the brain components back to its original position, and then double tap home to quit. And that's where we're going to get to. And then after that, what we're going to do is we're going to go through and we're going to add audio spatialization. So I'm going to quickly do the previous step and just so you all can see how that is, and then before I talk about the next thing. And then I'll demo all of this when we get to our pause slide. So, and that'll give time for any questions, so you all can really ask the questions that are burning in relation to this topic for you. So yeah, what was I going to do? I was going to add the reset child transform script. So on my sphere, in my prefab, I'm going to scroll down and add component and reset children complete. That's the name of the script. This is one of the custom scripts that come with the workshop. There's only 3 of them. Completed workshop scripts, assets scripts, completed workshop scripts. And now that we've added this to our sphere game object, looking at the script, we can see we check if we have children, we pull all those position rotations and scales, and using Unity functions, we reset them all by iterating on them. What it also has is it has some custom UI functionality that won't work quite yet because we don't have any UIs in our scene yet, but luckily the script should work as is because there's a null check. So going back to our scene, I'm going to go ahead and jump over to our control pointer. And in the control input, I'm going to add another reference on home button tap, single home button tap, add a sphere component, or add a reference to our sphere game object, and reset children complete. Sure enough, we have a reset child transforms script reference there. So save that. And then the next thing that we'll do for this scene is kind of a bonus UX thing, which is adding audio spatialization to our interaction sounds. And it actually goes a long way in helping ground our brain in reality. So now that we see our brain in reality, it's got some feedback sounds. If we have the feedback sounds actually come from where the brain is, it'll actually help the brain feel like it's a lot more part of our space. One of the fundamental design principles of spatial computing is the multimodal integration of all of these things, all the sight, sound, haptic feedback, all working together to help ground these objects in our physical reality and having them listen to our physical reality. So we're going to use MSA, which is Magic Sound Field Audio, which is part of the Magic Leap SDK to add spatialization. So all we need to do is add an MSA listener to our main camera, and then an MSA source to each one of our audio sources. And it'll go ahead and there's 2 Unity audio source settings that you need to enable, which is spatialize and spatial blend. So we're going to go ahead and do that real fast. Hopping back over to Unity and select all of the interactable components now that have, first we're going to set our main camera to have MSA listener. So go ahead, MSA listener. And this has some room properties that you can set. And then under brain prefab, we have sphere all the way down to set stem, and they all have an audio source component. So I'm going to go ahead and add this MSA source to it. And this will add some audio spatialization. And we notice that MSA source actually automatically sets the spatial blend to 3D and sets the spatialized box to true. So we'll go ahead and save this. And that's the last step of this 3rd module. And so I'm going to go ahead and build a device here for you. And here's callbacks to the different scenes for those of you who are still building on your own. So I'm going to go ahead, grab my device, hit play, boom. In device stream, got the prompt, accept. And focus on an area of the floor that should be catching up stream-wise for you all. Let's see, do we have a mesh? There we go. There's our location in the world. And sure enough, with my control pointer, I can grab the brain, send it flying around my room, rotate it, scale it, make it huge, make it small, and then force tap to reset it, and move all my individual components around. Sent that one flying. I don't even know where I sent that one. And then hit home, and all of the components come back, and we are happy. So, waiting for my stream to catch up. It's like two over Wi-Fi connections in one, from device to computer to you. Oh, this is so fun to watch this catch up. Pause it and come back to the slides and move on to part 4. All right. So in this part, we're going to basically add some UI functionality here. This is, so we've done a lot of pre-prep work to prepare all of our UIs for you. So there's nothing fancy happening with our UIs. Basically, we have, for each individual brain game object, we have an associated UI component for it that goes along with it. And each one of these we're going to drag into our scene. They're just world canvases using default Unity canvases and panels, just sized appropriately to fit on the Magic Leap scale. And we're going to go ahead and drag them all into our scene, and we're going to disable all of them at first. And then once we do that, we're going to attach the show UI script to them. And the show UI basically has a couple things. And I'm noticing for you all, really, like in of my brain prefabs or brain UI prefabs to be easier, as well as rename some of the functions. So the screenshots you see here are actually a little bit out of date. Just want to call that out so nobody's alarmed. But basically, the functionality is still the same. And there's kind of an enable disable UI or a show/hide UI that'll let you hide the UI on if you're actually dragging it. So there's 2 functions in show UI. The first one checks to see if there's a pointer receiver in the parent, and we're going to add this show UI script to each one of our UI canvases, and it's going to get a reference to the pointer receiver, and in the pointer receiver, it's going to check its state to see if it's dragging or not. So if it's dragging, we want to be able to use the bumper to actually set these UIs to true or not. So while I'm dragging and working on a game object, I want to hit the bumper, show the UI, and then I also want a general function to call when I reset the brain, to put hide all of the UIs when I reset the brain back to its original position. So that's what these 2 functions are for. And then once we have these 2 functions in our scene, there's a show UI modification, or we want to be able to reference in our reset child transforms function on the sphere to hide the UI and make it go all the way back to 0. So we're going to set that all up really quick right now, and it'll be a lot of dragging and dropping in Unity. And then once we have all of that set up, we're going to go through and make references to the control bumper. So on bumper down, we want to be able to enable and hide the UIs, and I'll show you how that all works. And then we're going to drag in some tooltips to be children of our controller. And this will allow us to see directions on our controller. So these are all just default canvases as well. These are all in prefabs. And this will kind of take us to the end of our instruction. So luckily, a lot of this is kind of default Unity stuff. But what the example really is showing you here is maybe how to set this up and how you can explore some user experience principles on Magic Leap with user interfaces, and how you might want to set them up to be friendly to your user. So really quickly, I'm going to go through the process of setting that up. Actually, it's 12:48 West Coast time. I don't know what time zone y'all are in, but acknowledging that, I think I'll just show you what the completed scene looks like, since I don't want to mess up the setup by going too quickly and send you all in workshop whiplash. So I'm just going to open up the completed scene, Brain 004 user interfaces, and point you all through kind of what the changes are. So in content, we now have our completed prefab, and each one of these have a child canvas that's associated with it, and it's disabled by default. And one thing to observe here is that while they're disabled by default, they're set to appear just right above the brain. And they're set to be kind of just like a little bit above the brain, and all the text is in copy. By the way, this is I am no brain genius. This is just copy from Wikipedia. So it's set to be disabled by default, and it's got one of these show UI scripts attached to it. And this show UI script gets a reference to the pointer receiver in the parents once it's enabled, whenever we click it. So if it doesn't have a reference to it, it gets it, and then it checks for the dragging state. And then if it's being dragged, then we set the game object to be active. And then we also have the other disable function, like I mentioned. So each one of these has that show UI script. Boom, 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 boom. And then saved. And then likewise, if we go to control input, you can actually see here, on bumper down, we make a reference to the enable UI function. So when we hit bumper down, we call that enable UI function. That enable UI checks, hey, if I got a pointer receiver, am I in a dragging state? And then if the answer is yes, then we show the opposite of what's happening. And yeah, and then as a child component to our control pointer, which is tracking the control, we've got these 3 tooltip prefabs that basically explain what is happening, what each of these controls are. And this follows the controller, so it's handy to always have your controller instructions following the control. So this UI is helpful. It's like, oh yeah, like what does my home button do in this application? My bumper do? There's instructions on your control right there to help you navigate what that is, or your end user navigate what's happening. And then likewise,
great question from the chat.
Oh yeah.
Is there some technology or techniques that would help us if we wanted to translate the digital brain to map onto a real life brain? Like if we wanted to anchor this digital object to a real world object?
Well, that's really interesting. I think there's a lot of ways to approach that. Like I'm actually really curious when that question is asked. Like when you say map it to a real world object, are you kind of saying like getting live data, sensor data in about the brain and using that, or are we talking about like mapping it to a physical human? So I guess I have real time mapping is actually it can be quite accurate if you do it. But at this moment in time, this is kind of more centered around being an educational application. So if this is something you all want to check out, definitely explore it. We actually have an application on Magic Leap World right now called Insight Heart that lets you kind of see a real life example of this type of application in practice, where you can see a human body and investigate a heart, and with much higher fidelity models and a lot more information about what's happening. This is the kind of thing that'd be used in an operating room type scenario to like teach about the human heart and the circulatory system, et cetera, et cetera, et cetera.
And if you want to learn a little bit more about the Insight Heart project, there's a link that was posted to General just now.
Yeah. So anyway, I'm going to go ahead and test this application and show you all of this in action, since we got just 8 minutes left. And since you all have the PDF of this slide deck, I really hope you guys get a chance to go rebuild this yourself if you're curious about how this portion of the application works. Boom. All right, move into device stream so you guys can see the wonderful lag of me saying something and then viewing it a second later. And for those of you that have this all set up, I'm sure you've all had a chance to play it. Those of you with Magic Leaps. All right, there's my brain. And here's my controller. And we can see I've got instructions floating by my home button, and following my controller that let us know what's happening here. Bonus points. One thing you could do is maybe write a script if you're feeling motivated to check and see if we're actually looking at the controller, and hide the UIs if we are and if we're not. So have them appear like, oh, like, I don't know what I'm doing. What am I doing? And if you were looking at the controller, like have them appear. That would be like a way to boost user experience in this application. Like, yeah, okay, like we can see there's intent from the user to actually try and figure out what the controller is doing, and then have the tooltips appear. And then that way, when you're actually like doing this kind of a thing, maybe you don't see the controller tooltips. And then if we drag a component of the brain out and we tap the bumper now, we can actually see some information about the right cerebral hemisphere. So I'm going to kind of put that over there, scale it a little smaller. set it back to normal, put that over there. And we have our our brainstem here, I think. This is yeah, it's sure enough, it's a brainstem. Gonna put that over here, and maybe I can maybe this will be like a multiplayer application in the future. Maybe if you want, you could like have another user view this with you. I don't know. I'm just riffing right now on ways that this is the first prototype and could be expanded to have more depth. So again, kind of the point of this entire workshop and kind of what we're doing here is to really show you how you can use Magic Leap Toolkit to kind of get you from zero to hero, or rather zero to rapid prototype really quickly. So all we had was a model with individual meshes, and over the course of almost 2 hours, we were able to get this far in terms of our interaction. We were able to like drag these things, move them around. Granted, we had some of this stuff done, but like when I was developing this application, it took me like just a few days to kind of get this functionality going in terms of like adding the UIs and things like that. And MLTK was so helpful in kind of just rapidly speeding this process up and getting us to this point. So, like I said, and to kind of show off that last kind of reset everything, if I hit the home button, all the UIs should disappear, and our brain comes back to normal, and our scene is well taken care of. So, hopefully that gives all of you an exciting. Oh wait, device stream is still lagging. Everything has come back. Has it all come back? Yes. It's back.
Looks like
I'm still tracking things around. Oh my gosh, this is so amusing. Oh, that's fun. But yeah, eventually I hit the home button in this device stream, and and you see me bring the thing back to center. But yeah, as I was saying before, this is kind of like a nice arrival point for a rapid prototype. And like imagine if you were as a developer kind of like working with an external client, maybe that's not a dev, how quickly you can kind of show them an interactive concept really quickly and get some feedback and know like, hey, is this something useful for my community, for my users, and actually get that in-device real-time feedback. And that goes a long way in building amazing tools for this device. So that takes us to the end of our presentation. And Nate, I think you had a few wrap-up things, and maybe we can use these last few minutes for questions.
Definitely. Yeah. Thanks so much, Kato. That was amazing. Had a great time following along, and thanks to all the mentors and participants who stuck with us to the very end here. I'm really impressed by how many folks made it all the way through, and super encouraged by that. So really would love to hear what you thought. Please drop a line in the feedback channel here on Discord. We also have a survey that will be circulating, and would love for you all to fill that out. Let us know if you have any ideas or ways that we can improve in the future. We covered some of this a little bit earlier, but for those of you who may have missed it, just want to talk through some of the wrap-up items here. So today we learned about control input, keep in front, place on floor, and control pointer. But there's so many other features of MLTK to explore. Please do check them out. And if you have questions about these, we will be on Discord for the rest of the week. And of course, the next time we run a workshop, you will be able to ask us questions then as well. Yes, here's a picture of what the survey looks like, so please check that out. One more shout out to ML Dev Jam, running until May 31st. This is an awesome program that we'd love to have you guys participate in. The theme is Hack Your Workspace. So there's a link to the registration page here. You can also hit us up in Discord if you have any questions about it. Please do apply for Access Hardware if you have a project or a team that you feel like would be a good fit. We are accepting applications and already have a couple or many amazing applications submissions already. So please check it out, magi.ca/hardware. And then please do check out our CHARIOT Challenge. That's the National Institute of Standards and Technology Challenge. $1.1 million for an open initiative to design Magic Leap interfaces for first responders to simulate emergency disasters using IoT data. So stick with us on Discord, follow us on Twitter. It's been great having y'all, and we're going to be going through all the feedback that you have and making improvements for next time. Be on the lookout for our next workshop. If you have any friends or colleagues who might be interested to join us for workshops in the future, please do let them know. We're going to be doing these very regularly. So thanks again, everybody, for joining us today, and hope to see you next time.
Awesome. Thank you all.